Welcome back to the Scotti-BYTE channel, and this is Scott. Well, it's been a minute since my last video, and I apologize for that, but I've had some family issues, some health issues, and then I've also been involved in a project which I'm going to describe here in just a moment, because as a result of that project, I had some issues in my data center. And we're going to talk about those. I highlighted this particular video with the title Ubiquiti Unifi and Software Bridges. You'll recall a while back I did a video about my new Minisforum MSS1 Max, and it's been a great system. And after I rebooted my data center, I noticed that although I could reach it and it was operating perfectly, the port itself on the switch was grayed out. Also, the speed was set to auto, and the connected MAC address was also grayed out. Very similar to what you see here on my Dell XPS 8930 being grayed out, and also the connection being grayed out, the speed set to auto, and the connected MAC address grayed out. However, the system is reachable despite what you see here on the switch. So why did I power down my entire data center? Well, the reason for that was because I had kind of run out of power in the house. My 40-year-old breaker panel was only 100 amps, and so I decided to get it replaced with a 200 amp panel that you see here. At the same time, the power's been pretty unreliable, and so you may have noticed that from time to time you're unable to reach some of my services. So what we've got here in the middle is an automatic transfer switch, and over here on the right we have our meter panel. Now this job ended up being a little bit more major than I thought, because we also had to bury a new underground cable, given the fact that the existing underground cable could only handle the 100 amps. So the end goal here was to install this really reliable next-gen Generac natural gas backup generator so that I don't experience outages in my data center. I apologize for this, the first of a few eye charts, but I felt like this is probably the best way to get this message across. For those of you that have been watching the channel for a while, you know that I have kind of a beginning video that's entitled Incus Containers Step by Step. And that tutorial shows you how to set up a Linux server and to install the Incus Container Virtualization System. So we started, when we did that, creating a software switch called Bridge 0. So what that does is it creates a Linux bridge named Bridge 0, and it attaches the physical NIC to that bridge, and then the host and containers share that same layer 2 network, and containers will get IP addresses from your main LAN. And we do that by not only running NetPlan to create the Bridge 0 device, but we also create a Incus profile by the name of Bridge Profile, and that Bridge Profile uses that Bridge 0 software switch in order to allow multiple containers to act as separate systems on the same connection. And so that kind of looks like this. You've got your firewall here, whatever router device you have, in my case a Ubiquiti UDM Pro. Here you have some kind of a managed switch, and we'll get into why that has to be in a little bit as opposed to an unmanaged switch. And then we have our physical device, our network device here, which is a part of our host that's presumed to be our Incus host when we build it. And that's going to have this Bridge 0 that talks to this physical device. And then off of it, if you've ever done an if config after you have your Incus server up and running and you have multiple containers, you'll notice that that if config command points out several VETH devices, which are all virtual Ethernet devices. Inside the container, each container has an adapter called ETH0, and each of those would get an address on your LAN. So here I've got some more information about traffic flow and so on, and you can go ahead and drill down to that if you like. So after power up, even though I could reach my systems and they were working fine, and in particular VMS Storm, I started to scratch my head because it had this auto speed and offline problem, and yet the system was working absolutely perfectly. So I dug a little bit deeper to discover what was going on, and basically the solution is to use something called Link Layer Discovery Protocol, otherwise known as LLDP. So LLDP solves this particular problem, and it actually solves it on more than just Unifi switches, but it solves it on any system that has a managed switch. So basically, here's what things look like, and I kind of went over this on the previous slide. We've got the Incus host, and if it has no LLDP, we have a software bridge, and we have all of these various containers. And each of these containers got its own IP address from the DHCP server, and they're all sharing that bridge 0 virtual switch. And so there are many MAC addresses that are really being presented by this one physical server, which is kind of how it was designed to work. So there's no unique device identity and there's no system information. There's just a whole bunch of traffic. And so as a result, any managed switch, and in my case, a Unifi switch, just has to guess what's out there. And we've kind of confused it. So all these MAC addresses are coming out and bombarding this one port on this switch. And so in my particular case, I had port 1 went to auto. Its client was VMS Storm. It appeared as though it was offline, and so it was unknown and generic. And so software bridges make the host look like many devices and lots of MACs, as I pointed out, but Unifi is confused by that particular fact. So what's the solution? The solution, again, is to use the Link Layer Discovery Protocol, which provides visibility. Here we've got the same scenario going on here, but this time we have the Link Layer Discovery Protocol daemon running, and it sends frames over layer 2 connection, and it does not require any particular IP traffic. It is kind of its own traffic on its own. So LLDP is a bidirectional protocol, meaning that a managed switch is required because the managed switch has to be configured to do LLDP, and the host has to be configured to do LLDP. So as a result of putting this in place, you now have unique device identity, system information, port information, capabilities, and devices are linked. And now it knows what the speed is. It sees the device online. And from the Ubiquiti Unified Network Controller perspective, the experience is 100% because it's actually there. So let's go on to the next page where we talk about how to install and configure LLDP on Incus host, or really on any server where you have something like this happen. It's just that the Incus host is a really good example of this because it's one where we produce many different MAC addresses on the same physical device, and that's what Bridge 0 does. So we can correct this problem by going out on your Incus host and doing a sudo apt update and a sudo apt install LLDPD, which is the link layer protocol daemon, and then the LLDP CLI as well. And then you can do the status of the LLDP daemon. And then we want to go ahead and enable it if it's not enabled after the install. And I think generally it kind of does, but that may differ according to your version of Linux. So then we're going to do a sudo systemctl enable --now LLDPD, which what that does is it goes ahead and starts the service, but it also enables it so that it will be started the next time you reboot the system. And then just to check it, we do a sudo systemctl status on LLDPD. So now LLDP service is started, and it will start when the system reboots. And then basically what happens is we have the Incus host talking to your switch, in my case, a Unifi switch. You've got LLDP advertisements that are running in both directions. And so LLDP operates at layer 2, and it does not use IP. And it even works before DHCP and helps tools like Unifi identify your devices accurately. And I'll go on to say that it helps any managed switch identify your devices. So the CLI gives you an important command. You can sign on to your host. In this case, I signed on to my VMS Storm Incus host, and I did a sudo LLDP CLI, and I said show neighbors. And that show neighbors command says, okay, here's your interface, which in my case was ENP97S0. That's the physical interface. And then it comes back and it says, okay, here's the real MAC address of the real physical device as opposed to any of the other virtual devices there. And it says the system name of the thing that we're talking to, well, this is the switch's MAC address, I should say. The thing that we're talking to is this switch called VMS Man Core Switch 310G. And then it says it's using UBNT, and it's a bridge, and we're routing. And so it's connected to port 1, and the system that we're connecting to it is VMS Storm. So now there's no doubt about the fact that our neighbor is that switch, and we're connected to port 1 of that switch. So in essence, what that means is it means that that is connected via LLDP, and it is presenting the correct information. So after you start LLDP, within around, I'd say it's 30 to 60 seconds, but maybe as soon as about 10 seconds, you're going to notice that when you go in and look at your switch statistics on your Unifi switch or other managed switch, you're going to see that it will correctly report when something is up and running and it's doing what it's supposed to do. I added this slide because I felt like it was really worth pointing out the fact that LLDP does require managed or smart switches to be useful. So it's because LLDP is a bidirectional protocol. That is, the host talks to the switch and the switch talks to the host. So on an unmanaged switch, we've got our server here with LLDP enabled, and it sends LLDP frames to the unmanaged switch, but the unmanaged switch ignores them because it is not a smart switch. So therefore, it's really not doing anything useful. Whereas on a managed switch, we have bidirectional communication. You've got full visibility, so therefore you get back the device name, the port connection, the capabilities, the link details, and information to do topology mapping. So as a practical comparison, we have this little chart down here. You can see that the unmanaged switch does see the LLDP frames, but it really can't understand them or show neighbors, build topology, or fix any of the auto or offline issues that I pointed out at the outset. And so a real world analogy might be that you would have an unmanaged switch plus a dumb power strip. In a dumb power strip, you can power anything with a clock, radio, what have you. And it will pass power, but it has no idea what's actually plugged into it. Versus if you have a managed switch as a device on its own, knows exactly what's connected to it. It can show the details of what's connected to it, and it can give you visibility if you have the right instrumentation. And the right instrumentation in this particular case is LLDP. And so LLDP does not require managed switches to exist, but it absolutely requires managed switches in order to be of any use. So let's kind of summarize this. Is there anything needed to enable LLDP on a Unifi switch? And the answer is that it is generally enabled by default on all Unifi switches, and no CLI or additional steps are required. And so, as an example here, I've got my situation where I looked at my devices. I went down to my VMS Man core switch number 3, which is my 10 gig switch. I opened the settings icon and I scrolled down to the advanced section. And as you can see here, there is no option to enable LLDP. However, in older versions of Unifi Network, there was an option to enable or disable it. Since this time, Ubiquiti has made that a default, so there's no longer a switch to turn it off or on, because I can't see any scenario where you would ever want to have it off, and so therefore they enable it by default, which just really makes sense. So LLDP is enabled by default on your Unifi switches, and you should not have to worry about going in and toggling the setting. It should just be up and running. If you're running another third-party managed switch, you might want to look for if there is a switch or capability to turn on LLDP to get it operational. So kind of the lesson learned in all of this is that I had to shut down my entire data center / home lab. I say data center because it keeps growing in size. I had to shut it down and power everything off completely. And when I powered back on, I discovered this particular issue. And so I thought it was worthwhile to highlight. When it comes down to looking at things in your home lab, you want to make sure that you understand everything you have there, and infrastructure is everything. It's not just about hosting a particular app, but it's making sure that the infrastructure works properly and gives you the information that you need in order to correct any potential problems that you will at some point experience. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.